Okay, 4 or 5 notes, video number 2. So now we need to write a system of inequalities that is shown in the graph. So the one thing that might be hard on your paper because it's in grayscale is to know what the overlapping region is, right? So let me get my proper weight of my pen. Oh, there we go. Okay, so this right here, this space, that's too big, that is the overlapping region, right? So we're trying to find the solution space, the proper inequalities for there. So let's start with the red line, okay? So we'll call the red line number 1, and we'll call the blue line number 2, okay? Now, let us recall that these are going to be in slope-intercept form. So y equals mx plus b. Now, the only difference is the equals will not be an equals. It'll be an inequality. All right. So for the first one, right, let's start with the inequality symbol. So y. Now, for this red line, number 1, that is a dashed line, and the shading is going below, this way, below. So because it is dashed, it's not going to have an equal to, and because we're shading below, that's a less than. So y is less than. And now our job is to find first the b value. So again, when you're trying to do this, you first find the b value, and then you count the slope, the m value. So for the red graph, it looks like the b value is right there, and that's at 1, 2, 3. So it looks like my b value is a positive 3. And now if I try to find another nice point on this dashed line, I think that this is another nice point right there. And to get from my 3 to that second point, I must go up 2 and right 1. So my slope is positive 2 over positive 1, which just simplifies to 2. And there is my first inequality. Y is less than 2x plus 3. The second one. Okay, same thing, y. Let's start with the inequality symbol. So for my second graph, it is a solid line, and now the shading is also, no, it's not also. The shading is above. Shading is above. So that's going to be a greater than or equal to. Solid line, greater than. Now, the b, and again, it's kind of covered up by the red here, but that b is right there at that 4. Okay, so there's my plus 4. And now, the next point, I think, is this one right here, which means I just have to go down 1 and right 1. So that means my slope is down 1 and right 1, which is a slope of negative 1. And you could put the 1 with the x or just put the negative sign. It doesn't matter. And this, to me, is going to be my system of inequalities. Y is less than 2x plus 3. Y is greater than or equal to negative 1x plus 4. And before we leave this problem, let's go ahead and check it. All right. Again, you have a great tool in Desmos to check your work. So let's go check it. All right. So let me clear this, clear this. So I'll type in the first one. So y less than is right here, is less than 2x plus 3. And then we'll type in y is, I got to move my little tools here. Maybe I'll move it. Sorry. There we go. And then we'll type in y. Y is greater than or equal to negative 1x plus 4. And there's the picture that they have provided me, right, based on my inequalities. So let's take a look. Shadings on the right, solid, dashed. Let's see. Shadings on the right, solid, dashed. I'm pretty sure that's it, right? It looks pretty close. So I'm confident. So use Desmos to help you even on that question. Okay, last but not least, our word problems, right? I love our word problems. So we have Malia has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one item. What graph shows the possible numbers of water bottles and pairs of socks that Malia should buy? Okay, so this is a system of equations. Now, notice the first thing is I only have the first quadrant. So because I only have the first quadrant, what I'm doing is I'm limiting my x's and y's to positive numbers. Okay, so that's important. Okay, now I'm going to bring this up to get it out of my way. Okay, all right. So I see two totals, right? The first total is 500 and the second total is 200. Now, each of these is going to require an inequality, and we'll do that in a second. But let's think about, okay, what should X be and what should Y be? Well, if I look over here, right, I have these socks and water bottles, and it says she needs to purchase water bottles and socks. So I'm going to let X be the water bottles and Y be the pairs of socks. Okay, so the 500 is the money, right? And if you look at the picture, every water bottle costs $2, that's 2x, plus every pair of socks costs $3, that's 3y. Now the other one, there are no other numbers, so it's just going to be x plus y, like we've talked about in the past. Now, the inequality symbols, right? If you look at the problem, Malia has $500 to purchase. Think of this like a budget. Budget you can't go over, so you can't be greater. This cannot be greater than 500, so it must be less than or equal to. The second one, she wants to buy a total of at least 200 items. What that means is 200 is the smallest amount. So you can't go less than 200. So that means it's greater than or equal to. Equal to 200 or has to be greater than. Here's our system. Okay, so now we're going to use Desmos to graph this. We're going to pick an appropriate scale and draw it back here on our picture. Okay, so if I take a look at Desmos here, I'm going to plug these two in, and then again, we're going to mess with our scale. All right, let me get there. It's up here. Okay, so delete, delete. All right, so the first one, again, let me move my tools out of the way. So the first one says 2x plus 3y is less than or equal to 500. That's the budget, right? That's the money, okay? And again, you see the whole screen is shaded. That doesn't make sense. And then the second one, we're letting x plus y be greater than or equal to, so at least 200. Okay, so if I take a look at this, all right, I'm going to press the wrench. So, you know, if we're trying to buy 200 of each item or the items, let's go from 0 to 200 each time. Because again, that would be the maximum number of each we could buy if we're doing 200 maybe. We'll see. Maybe I'm wrong. All right, let's just start there, 0 to 200. Because we're not going to buy more than 200 of each. Yeah, okay, I like that picture, right? And again, I'll kind of slide it. So there you go, right? So if you want to zoom out just a smidge, right? So maybe that's better. So if you go, you know, like 300 each direction, okay? For the gray one for the money, you can see that you're going from about 167, you know, to about 250. So I'll write those down. So 0, 167, and 250, 0. So we'll write them down up here. So you can write them down too. So for the, I'll do this in, let's do this first one in blue. So we're doing 0, 167, and 250, 0, right? Okay. And then for the, and we're shading below, right? We're below the gray, right, underneath. And then, and we're solid, right? So be aware of that, and we're solid. Okay, then for the red one, if I click on those dots, I think it's at 200 and 200, which is pretty simple. So nice, so we have 0, 200, and 200, 0. And then we're shading above as well. I'm sorry, we're shading above, I always say as well, and it's also solid. So somehow, some way I need to put these numbers on my coordinate plane as best I can, right? Again, it's a word problem, it's not easy. Okay. All right, so let's go back to here. Okay, let's open this up big. All right, so if I take a look at this problem, so I'm letting X be water bottles. So remember to, I think it's good to label. So X is your water bottles. And then Y is your socks. Okay. So if I want to get, you know, 250 on there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can almost count by twos. You know, if I add another one like here and here, that'll give me 260. So let's count by I mean, not by 2s, by 20s. So 0, 20, 0, 20, right? So I need to go for the first one, 0 to 167. So 20, 40, 60, 80, 100, 20, 40, 60, and we'll go almost to 70, right? So there's 167. And then I'm going to 250. So 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, there's 60, so 250. And there's 250. Connect those as best I can with a solid. And we're going to shade below that. Right? This is our budget. So we're going to be inside the triangle here. Okay? And now if I do the other one, so 0, 200. So 20, so this is 160, 180, 200. And this is 260, 240, 220, 200. All right, there's my two 200s. I'm going to draw a solid line as best I can. And for this one, we're shading above. So the spot where we're crisscrossing is this space right in here, where we shade below the red and above the blue. Okay? So it is points in this region that are going to satisfy both, and also points on the lines. So you can use both lines because it's solid, and you can use the intersection point. So this counts. So the intersection point counts if you want to. All right. Now if I take a look here, let me see if I can guess one. So again, I did a terrible job drawing my lines. But let's see this point right here. I'm going to do it in green, right there. Let's hope that works. So that point right there is 20, 40, 60, 80, 100, 20, 40, 60, 80. So that's going to be 180, comma, and then it's going to be 20, 40, comma, 40. So that'd be 180 water bottles, and that'd be 40 pairs of socks. Okay? And again, just quickly, right, if you add those together, so 180 plus 40 is 220. That is more than 200, okay? And if I multiply them by how much they cost, so 2 times 180 plus 3 times 40, this is 360 and 120. That is 480. That is less than 500. So that satisfies both inequalities. So this would be a combination of water bottles and pairs of socks that Malia could buy that satisfies both inequalities. Okay, again, word problems, they take time, but it's what makes math make sense. All right, so again, it's important to take our time to go through them together carefully. All right, thanks for watching. Good luck on your practice.